Okay, let's try to understand what is wave function in relation to Schrodinger's equation, which is a basis for explaining the structure of atom, well, how the electrons are distributed, what is the position of the electron, what will be its velocity, what will be its position. So it's the mathematical expression uh, which explains the distribution of electron in an atom is the Schrodinger's equation, which is this one. Hamiltonian H psi is equal to E psi, where H and this particular symbol it represents it is known as Hamiltonian, and it is a mathematical operator. And the psi represents the wave function. E means the energy of the system. For example, this is an atom. We have nucleus in the center, and the electrons are revolving, moving around the nucleus. So we will try to solve the equation for this electron. We'll try to find out so that the electron must have a particular, it cannot have any energy, it will have some specific energy. So based on that energy, that possible special energy, what will the value of the wave function that corresponds to that energy. So we will be able to calculate the wave function of the electron, which means the wave function is just a number which depends on the coordinates of the electron, like the x coordinate, the y coordinate, or the z coordinate, giving the coordinates, the x, y, z coordinates, whereas it is an x, y, or z axis. So what are the coordinates of that electron, which will tell the exact position of the electron, and depending upon that coordinates, we'll be able to, and depending upon the energy of the electron, the specific energy the electron will possess, we will be able to calculate the wave function, this value of psi, right? And it is also known as atomic orbital for a single electron system or similar system like that. Even though the number of, for example, the lithium ion, the helium ion, and the beryllium ion, what do you have? They have different number of protons in the nucleus, but they are ion in the sense that only one electron is there. So it will be called one electron system. For those one electron system having only one electron, we'll find out, and depending upon the energy, we'll find out what will be the wave function, right? But so wave function, it's a mathematical function. It's a wave function, so it doesn't have a physical meaning, but it's just a number that it will correspond to the energy of that electron. But it doesn't have a physical, because by looking at that number, looking at the wave function of that electron, we won't be able to say anything about like we want to say what the physical meaning of that's the sign. But when we do the square of this, and whatever the value of the psi is there according to this equation, when we solve the equation, when you do the square of this, it will give what? It will give the probability of finding the electron in that particular point. For this particular for this particular position of the electron, the square of this, the square of the wave function, the wave function that we have calculated from this Schrodinger's wave equation, will be able to calculate this one, that one, and it will give if its value is large, it means that there's more probability of finding the electron. If its value is less, it means that the probability of finding the electron in this particular point is less. So it gives the psi doesn't have physical meaning, but the square of the psi, or square of the atomic orbital, or the square of the wave function will give you the probability of finding the electron in that particular point, or in that particular place around in an atom around the nucleus, right? But although it's easy to calculate to solve the Schrodinger's wave equation for one electron system, but when it comes to multi-electron system, like having 2 electrons or 3 electrons or 4 electrons for other atoms, for elements of other atoms, it's quite difficult, and it will not be able to calculate the value of psi. So we will be like using an approximate method. Like we won't be able to say, oh, it's exactly here. We'll just say that the probability that we'll often use the word probability more. We'll only say that we will never say that, oh, the electron will be here. We will only say that, oh, the probability of finding the electron is here, is more here or less here, is lesser or is more or is greater there. We will never say it's exact the electron will be here, right? For multi-electron system, it becomes difficult to calculate the Schrodinger's equation. So we'll only talk about, we'll use approximate method and we'll use the term probability of finding the electron. And for although for one electron system, this energy of the system, it depends on the value of the n, the principal quantum number, right? And but when it comes to multi-electron system, which contains more than one electron, the energy of the energy of the system, it depends not only on the principal quantum number, but on the azimuthal quantum, the L, the azimuthal quantum number. So for one electron system, the energy of the system depends on the principal quantum number n, and for multi-electron system, the energy of the system depends on the sum of the not only on the principal quantum number but also on the azimuthal quantum number n and L. And you know that the principal quantum number, the azimuthal quantum number, and the magnetic quantum number, they are the quantities that will be needed, that will feed it in the Schrodinger's wave equation to solve the equation. They are the natural the numbers that are needed, quantum numbers, natural numbers needed to which will help us to solve the equation, the Schrodinger's equation for that particular system. Right? I hope this is clear.